I have the pleasure to announce Professor Björn Schuller, who is professor and head of the chair of Embedded Intelligence for Healthcare and Well-being at the University of Augsburg, and also professor of Artificial Intelligence and head of GLAM, Group on Language, Audio and Music, hope I got that right, from the Imperial College of London. So, and he will, I'm quite curious because the promising title of his keynote will be Characterizing Leader Qualities from Audio and Video. So the floor is yours.
Thank you very much. Oh, wow. And welcome everyone to this presentation. So you might wonder how this fits in, and in fact I had been offering 3 topics. This one was chosen. And maybe because it's humorous, we will be seeing humor recognition, so our system would already have hopefully detected your laughter now, for example. Now, in the previous talks, I have heard somebody already asking, wouldn't you want to include sentiment? So we know that sentiment analysis in trading could be of interest. Here we have one of the ideas being that you analyze charismatic, humorous, and so on behavior of leaders while they're giving press interviews, for example, or announcements or things like that. And you could be using that to get a first impression of how they react also for trading. But there's many other applications like coaching leaders in being more charismatic. There's analysis by colleagues in Passau, how humor of the leader or the coach in a soccer team, we will be seeing that, influences the team performance. So a lot about applications. And the idea is that we will be using artificial intelligence, audio, video, text, whatever we got, to recognize leadership traits, humor, and things like that. So we will be seeing a first video where you can see such an analysis, and in the upper left corner you will be seeing arousal and valence. Valence from left to right, meaning from negative to positive sentiment or valence, and arousal from bottom to top, so how aroused is the person in the video.
Please say hello to start.
Hello.
I didn't understand your response.
Allô.
Please say hello to start.
Hello.
I'm sorry, sir. I can't understand you. Could you please repeat your response?
Hello.
I'm still waiting for your response. Please say hello to start.
Hello. Hello. Hola.
Calling iRabbit International Help Desk for assistance.
And so maybe you could see how the dot was moving when she spoke to the middle, more or less, and when he started, it was down in serene, positive, and at the end moved to more and more negatively aroused, highly aroused. So that's the idea. We have an AI, that's an actual AI that's working in real time. We have this, for example, now as plug-in Unity, if you are a video gamer, and Unreal Engine. Similarly, we will be seeing, other things that we can recognize. We have been coining this field under the name computational paralinguistics, or maybe a more known name is affective computing, anything to do with human affect and computers. Computational paralinguistics is more or less the same idea. It started from speech, so unimodality means it's looking at speech and spoken interaction at first, but you can also do it multimodally. And when doing so, you could do 2 things. You could synthesize behavior. We are also doing that part, so having an AI, a virtual agent or something like that, being humorous, being charismatic and things like that, or you could analyze. That's what we're talking about today. And what you can analyze is different states and traits, where traits are something that is more permanent, like my age, my gender and things like that, and states are more short-term, things like my emotion, my humor and the like. So I want to start with leadership. That's kind of more on the trait side of things, and I will be guiding you through 3 more chapters like that one. And that's a rather older study we did with the University of Wuppertal. They had been labeling 143 leaders from business in 400 speeches given online at YouTube, such that it is reproducible, and had been using the CLT labels for leadership qualities or leadership traits. What you're seeing here is the distribution after the labeling by 10 annotators in these videos. So it's somewhat balanced, usually around 0, and it's normalized to -1 to 1. and depending on the trait, you have a different distribution here. You can see we have things here like charismatic, visionary, inspiring, upright, decisive, performing, team integrating, non-malicious, diplomatic, self-confident. So 10 different attributes we would want to recognize, just like the emotion in the previous video, automatically from the voice. And from the voice means from words spoken and from the acoustic sound of the speech. Now, when we had the labeling, we could see that the agreement, as you would expect, is quite different from state to state. This is a confusion matrix, meaning that it's, for example, showing the highest correlation is actually between decisiveness and self-confident behavior. You also have high correlation between inspirational and visionary, that makes sense, or charismatic and inspirational. So some of these traits, in other words, are more correlated than others are after the annotation, so it's not really independent. What you can also do is do a cluster preserving downscaling by NMDS, and you can see that some of these are then found more close to each other, like decisive, self-confident, performing, or visionary, charismatic, inspiring. We have already seen from the agreement before. And ultimately, we use this to do 3 bigger clusters, namely achiever, charismatic, and team player. On the right-hand side, you can see the agreement across the labelers, and with these, we have a somewhat reasonable agreement. So in other words, we're trying to find either 10 different traits automatically by themselves, or 3 cover classes. Are you an achiever, listening to your voice, listening to what you're saying? Are you being charismatic? Are you being a team player? Now again, the idea being that we can recognize this. If somebody talks, you could even be thinking of job assessment. This is being done already. So if you want to search a new CEO, you can hear how charismatic does she sound, or how team player-esque. And after the automatic analysis, we have a lot of numbers here, but the major message is that we're doing 2 things. We're doing an acoustic analysis, we're doing a linguistic analysis, and we do this on different time levels, meaning after the whole speech or after each chunk of speech, which could be a few words together. Maybe you can simply see that some of these are highly significantly above chance level. For example, achiever worked fairly well. This means 1% significance level, and the p-value meaning it's lower than that. It's 1 per mil actually even. And overall, you can see that if you have just a binary classification, we're usually above chance level, but maybe the number of that paper to take away was 72.5% for achiever or not. That was the one trait that worked best from these cover terms, and it means that if you have a random guess, you would be at 50%, 72% gives you a feeling it works above chance level, but it's not perfect. That was 2012. By now we have much better systems, but we didn't rerun this study. And instead, I want to give you a bit of an insight on today's approaches, which are quite more deep. We've been hearing a lot about deep learning already today. And I have examples for you from personality. Now for personality, you have similarly different models, different dimensions, like the team player and so on we've been just seeing. And maybe the most prominent one is ocean: openness, conscientiousness, extroversion, agreeableness, and neuroticism. We have been running challenges where we invited the research community to recognize these from the speech, from the words, and from the video camera. So from my gait, from my movement, from my body gestures, from my facial expression, and so on. I just picked for you one example today, and that is looking into NLP, so natural language processing, into the words spoken. And if you're more into machine learning, there is 4 different approaches considered here. The lowest one here is following Joachim's in the mid-90s. What you would have done to recognize something from words is you would have formed a word vector by taking each word in the vocabulary, building a large vector for each word in the vocabulary, counting how often is this word inside. So you have a very sparse vector with a few ones, twos maybe, because a word occurs twice, like the or a, and many zeros because most of the 10,000 or whatever words in the vocabulary are not present. Then you can do some normalization. Term frequency is this, what I just said. Inverse document frequency means you scale it to the size of the text. And then use a support vector machine, a neural network, MLP, whatever, to do the actual classification. That's very basic. The next more elaborate is that you use deep learning in the sense of you use word embeddings like word2vec. Maybe some of you know word2vec. Basically, it's models that have been trained on large amount of data. Next, most recent is Roberta. That is a self-supervised learned text modeling approach, which then led to GPT, and probably all of you know ChatGPT. And that's actually the point where it's getting exciting, because the difference is that here we train the encoding and the decision making completely from the data that we have. Whereas here we are having massive data in the front end part here that has been used to train a representation, but we're still using only data from the personality task as a so-called downstream task to make a decision on personality. Whereas here we have ChatGPT and we ask it, is this an open or non-open person if she or he says this or that? And get a response. And this response means we did not train anything on personality on purpose, but it's actually emerging. That's emerging AI, emerging artificial intelligence. Can we actually do something that we haven't been explicitly training for because we have been using a very large model? So what we did ask for the big 5 personality traits is, what is your guess for the big 5 personality traits of someone who said, and then the text that we're using to be analyzed, answer low or high with bullet points for the 5 traits. It does not have to be fully correct. You do not need to explain the traits. Do not show any warnings afterwards. Okay, that's just to make it a similar response each time. Now this is where it's exciting to see the difference. So from right to left this time you have the traditional model from the 1990s, completely trained only on the corpus. Then you have the 2 modern models, which are also using large databases to pre-train for the representation. And finally ChatGPT, which has never been trained for these tasks. What we can see is that it's not falling too much behind on some of the things. So it's, for example, even better on conscientiousness than the traditional model. But something that still includes some downstream training like Roberta is usually better. Maybe interesting is this task, which we also took along the way, sentiment analysis. You've been talking about this today. So this is basically saying, yeah, thumbs up or thumbs down from some text. And the surprise is ChatGPT has been the best model. Now I have to say that ChatGPT included somewhat of downstream training on sentiment analysis. So it's a bit of cheating, but it never had suicidal risk, for example, and it never had these personality dimensions. Suicidal risk was something where we had the last tweet database, people committing suicide after tweeting something, and this database was done after the training of ChatGPT, so we're sure that it can't be inside ChatGPT's model, and still it gets a very good performance comparable to 2 more traditional approaches. So at this point we feel that we have entered a new era of AI, the foundation models era, as it is framed by colleagues. The foundation models being marked by homogenization, so people all using the same models more and more because they're trained on terabyte, petabyte, whatevers, which are too large to be trained at home, let's say. So we're all using now these GPT models or whatevers, and we just fine-tune a bit or to do some downstream task, or not even that, as in this example. And they're coined by emergence. And this is the emergence we're seeing here. So tasks they have never been explicitly trained upon are working. So we're very curious to see this along the board in other tasks. But I will move on to the next thing, and that is charisma. And for charisma, we changed a bit because so far we have been looking at one person at a time. Is she open or is he whatever conscientious? Or an achiever or not. Now we're looking at the interplay between 2 persons. And when I look at the interplay between 2 persons, I can find, for example, things like charisma. Depending on different models you're using, a more popular one is on the right-hand side by Fox-Cabane. You can say charisma is coming from being present, showing warmth, and having power. Ultimately, you're answering the question, is the person, in this case maybe me, if you want to say if I'm charismatic or not, able to help me, and will I help you? Then I would be charismatic. Now, able to help you means I have the power to do so, and I will help you comes from presence, so I'm taking note of you, and warmth, so I would be likely helping you. Now we can measure this, for example, by mimicry or adaptation, the presence and the warmth. For example, who should I be taking? Maybe you. You're sitting a bit like this now, and I might try to imitate that to come across charismatic, because if I copy your behavior and you don't notice that I do it purposefully, you would notice that I'm present. I take note of you, kind of. Yeah. I will also show warmth because I'm, showing empathy or something like that. Of course, I can't overdo it, but measuring this kind of synchrony between people would give you an impression of presence and warmth. A more scientific model is the one by Chkai and colleagues, where you have two major factors, influence and affability, but you can see they have similar concepts. So influence also has presence inside, leadership, influence, and maybe here in affability you have more of warmth aspects like smiling, comfort, getting along. So the idea is that we want to measure the interplay between people. This could be done on all the levels we have been talking about, on the textual level, on the visual level, on the auditive level. And I give you one example from a study where we have been training autoencoder deep neural networks per person. If you know autoencoders, they are doing the following. They encode the input and try to reconstruct the same as an output. So it's a neural network that does nothing else but produce the same output as the current input. Sounds weird, why would you do that? But the point is that it's a so-called compression autoencoder, so it has a bottleneck, and that means it does not have enough parameters to perfectly reconstruct the input, so it's kind of learning a compact representation of the input. Now if I train an autoencoder on him and run her through this autoencoder, I can see how much the reconstruction error is. And if I have a large reconstruction error, it should mean that she's behaving quite differently. That's the basic idea here. I can do the same for both speakers and can run him through her autoencoder and vice versa and get a measure of how similar is their behavior. We have been doing this for words, for acoustics, for visual behavior. And you can see we have been doing it across 6 countries. So China, Hungary, Germany, England, Serbia, and Greece, quite differently, we hoped. And I have a coarse heat map here for you. The darker the red, the more they have been in synchrony. So you would say maybe no surprise with your expectation. The Greek were having most synchrony, so maybe most warmth, whatever, and the English had least. Bad for us at Imperial College. Okay, let's look at a video for this. We have 2 German participants in the study, and we're focusing for you on the pitch, so the height of the voice. And as they speak, they're synchronizing, meaning that one lowers her voice and the other one raises her voice. And why would you do that? Again, to be likable, to be sympathetic to each other.
Hallo.
Hallo.
So we have here a pitch of speaker A and B, and here we have the delta, where here we have 0 delta.
Ja, wie fandest du den? Fand ihn zu lange.
Ja, ich fand auch zu lange. Also ich finde es eine coole Idee, so immer mit den schmutzigen Händen darunter, aber ich fand auch, dass es irgendwie zu viele Beispiele waren. So 2 oder 3 hätten schon gereicht.
Doing a bit of fast forward.
Professionell wie der Wasserhahn.
And maybe make a short break. You can see that they already started to meet a little bit, and this delta curve is getting here where it's closer to 0, and I'll just play maybe the end.
Sind die anderen im Raum?
Nee, wir dürfen nicht zuschauen. Ja, okay.
Komm ich gleich wieder hoch.
Ach, du bist unten?
Ja.
Okay.
Okay, and you can see that towards the end they kind of aligned in pitch. Now we could be doing the same with other measures like the tempo, like the energy, so how loud they speak. And if they want to be likable, if they want to show sympathy, you could see this meeting sort of on different features. From that you can also get hierarchies, for example. So the boss would usually tend to be less synchronizing, and the employee would be trying to be more synchronizing. So in other words, we have an approach in unsupervised training to measure synchrony or even beyond. From that, let's go to humor. This is, as said, done with Passau colleagues who are very interested in finding team influence, if the leader is humorous or not, team performance. We use the model by Martin, where we have 2 dimensions for the humor, that is from negative to positive, so sentiment again, and we have from self-directed to others-directed. So if I'm negative and direct my humor towards others, I'm aggressive. So if someone makes a mistake, for example, I will often tease them about it. If I direct it towards others, but I'm positive, I'm affiliative. So I laugh and joke with my friends, kind of. Yeah? So, and similarly, if I am self-directed and it's negative, I'm self-defeating, and if it's positive, I'm self-enhancing. So we're not just recognizing humor, but kind of the type of humor and its kind of purpose by having the dimension sentiment and direction of the humor. Now, in Germany, you can guess what people love to look into is soccer. So the colleagues in Passau had the soccer coaches of the German Bundesliga and had 10 of them chosen and had gotten personal access to press interview sessions. So you can't make them public because it's also not aired material partially. But we could run a challenge on this, and we had 11 hours of humor or non-humor annotated by 9 annotators in these press conferences. Now you see from left to right the annotators and the coaches, and you can see that there is some disagreement on whether somebody's humorous or not and how much humor they perceive depending on the annotator. That's an ever-prevailing bottleneck in our field, that it's subjective and we have to deal with a lot of subjectivity in the data. And you can see that depending on the coach, they have been more or less humorous. The right-hand side, humor is differently scaled than the left-hand side, which is 10 times scaled. So they have been most of the time not humorous. It looks like it's more humorous than it is. The most humorous coach being 10 times humorous. So we're kind of looking for a few moments of humor. And we also have the distribution now, depending on the coach, how much they are aggressive, self-defeating, self-enhancing, affiliative, because we have this sentiment and direction. And from that, they are hoping to get an analysis, how the team will perform. And in soccer, you have a quantified outcome, which team will win and by which score. And already they are starting to find quite a significant correlation between these kind of analysis and the team performance in relation to their to their natural usual, that's it, to the usual performance. So it seems like, yes, you can derive something from how humorous the coach is and at that day. Now, in terms of recognition, we use text, audio, and video and run it through different approaches, which are state-of-the-art, and then do some final modeling. In the interest of time, I'll cut that a bit short, and it's quite a bit depending on the coach, how much or which type of information is best. Sometimes for humor, text could even work better, but usually it was video in our case. Then we have the direction and the sentiment. And roughly you can see recognizing if somebody's humorous or not works fairly well. The direction works reasonably well and the sentiment works reasonably well, so you can actually automatically transcribe large amounts of data to do this. We've also been working on personalization and got a little bit of improvement. So we have an untrained model and then fine-tune this model after training it on all the data for a particular coach, and then get a little bit of an improvement. And by late fusion of different approaches, we can further improve, but video features are best for humor alone. For the direction, it's the text that is giving you best results. So depending on what you're after, different modalities make more or less sense. So from that, just one slide on the application of all this. It's not actually in there yet, but where we want to put it next. And that is trading. So here you can see our latest human aligned trading approach. We're using deep reinforcement learning, using different companies' stock market course and development. This is just some examples here. And we're using reinforcement learning to train the AI to do the best possible trading. But we train it, pre-train it, human aligned, meaning that we have some human traders as starting point and not random initialization. And from that, get a reasonable development. The orange curve here is our human-aligned reinforcement trading. and the blue one is buy and hold, and as long as nothing goes down south, let's say, buy and hold works, but then if it drops, it's not the best option, and the human-aligned trading can be good. But the real point I want to make is just that now we're starting not only to use sentiment analysis in general towards the company on the internet, but we want to see if in reinforcement learning we can use these soft factors, looking at CEOs or others in more or less real time on the net. So, as an outlook, we want to do leader feedback apps. I have my smartphone on the table. It could warn me, now you're not being charismatic, you're not being present. You don't look enough at the audience. And actually, we have been starting to do that in student presentations. So our students now have a warning when their presentation is not whatever, humorous, emotionally diverse enough. You could have the integration I just said into AI trading, application in AI leadership. So that's a synergy or a synthesis side of things. So we're starting to generate. I haven't shown that today, but we're generating voice that sounds more or less humorous, charismatic, and so on. So if AI takes over leadership, it has to be able to do that. And one thing that we've just very recently started to do is defensive communication. So recognizing if communication is defensive. We have good results on that, on finding that automatically, and we also want to include that next into our forecasts. With that, thank you very much for having me today and for bearing with me before cool laser tags, restaurants and other things. Thanks a lot.
I wonder when I can get the professor feedback app, and I wonder if I get a better feedback than from my students. I don't know. So what's the time horizon for the leader feedback app? When do you plan to start?
There for us, it's in better phase with our students. So we actually have it with our students right now. And the whole software is, as you've seen in the video clip, running to get arousal valence, but it's also about acoustical features or movement features. If I'm moving too little, if I'm not varying my intonation, but I all the time talk like this very monotonously, it also gives me more diverse warnings.
I wonder if it includes if someone uses a blackboard. Because here still we have some kind of traditional auditoriums with blackboards, so maybe this might affect the app as well.